Hello class, in this lesson we're going to learn how to perform division with radicals and how to rationalize denominators. So a little warm up, I'd like you to compare the values of these two radical expressions and see what you get. So in the first one, 100 over 25 is 4 and the square root of 4 is 2. In the second one, the square root of 100 is 10 divided by the square root of 25, which is 5. That is also 2. And that turns out to be true whenever you're dividing and the radicands are both non-negative. So here's the quotient property for radicals, very similar to what we learned about the product property. And here's an example. So we can rewrite the square root of 16 over 25 as the square root of 16 over the square root of 25. The square root of 16 is 4. The square root of 25 is 5. I'd like you to try these two examples, and then we'll look at them together. So in example A, similar idea. We're going to split this up, take the square root of the numerator and the denominator separately. And the square root of 4 is 2. Square root of 49 is 7. 2/7. B, same idea. But the square root of 13 does not simplify. There's no perfect square aside from one that'll go into that. So that just stays the same. And the square root of 100 is 10. Example 2. Now, one way you might think about going around solving this problem is to simplify the numerator. And you know square root of 4 is 2. That's one way to do it. But it's actually, you can make it a little bit simpler than that. If you apply the converse of the property that we've been doing, and you combine these into one radical sign, you'll see that you just have 12 divided by 4, which is 3. So this is really the square root of 3. Now, when we were talking about simplest form, the second part of that statement was that there's no radical in the denominator. So if you look here in this expression, we have the square root of 3 over the square root of 5. And we want to get rid of that square root of 5 in the denominator. So how can we do that without changing the value of this number? Well, the only thing we can multiply a number by without changing its value is multiply by 1. So we have to multiply by some form of the number 1. So how can we get rid of that square root of 5 with some number that's equivalent to 1? Well, we know the square root of 5 times the square root of 5 is going to give us the square root of 25, and that's a perfect square. So that's going to do the job. So if we multiply by the square root of 5 in the denominator to make this number equal to 1, we'd have to also have square root of 5 in the numerator. So that's equivalent to this expression. Multiply the numerators together, we get the square root of 15. Multiply the denominators together, we get square root of 25. Square root of 15 doesn't simplify, but the square root of 25 is 5. And these numbers are equivalent, but now this one is in simplest form. We can double check that in the calculator. So if we look at the square root of 3/5, we end up with this decimal. And if we check the square root of 15 and divide that by 5, we get the same decimal. So this shows that the numbers are equivalent, not necessarily that they're both in simplest form, but it shows you that at least you know those two numbers are equal. So this process is called rationalizing the denominator. We want to get rid of that radical that's in the denominator, so we turn it into a rational number. Just the denominator is going to be rational, though. I mean, the numerator could be rational too, but that always the denominator has to be rational. So we want to get rid of that square root of 2. So what are we going to multiply this expression by? We would multiply by the square root of 2 over the square root of 2. And square root of 2 times square root of 2 in the denominator gives square root of 4. Multiply the radicands in the top, we get 6 times the square root of 6. And the square root of 4 is 2. And 6 divided by 2 is 3. So when we're dividing, we follow the same rules as before. You divide the numbers in front of the radical sign together, and you divide the radicands together. So this doesn't simplify anymore, so we're good. Example 5. Read this problem to yourself, try to solve it, and then I'll show you my solution. So it turns out that they're both correct. It tells us that. So we want to show why. Well, DeMarcus, all he would have to do is rationalize his denominator. I'll get rid of that square root of 2 in the denominator. So multiply that square root of 2 over square root of 2. And we end up with square root of 2 over square root of 4, which is the square root of 2 over 2. So they are both correct. Those numbers are equal. In this lesson, we learned how to divide radicals and how to rationalize denominators. Thanks for watching this video.